Nope, I added Marge next. Marge is the Orpington. She's a sweetie. She's the most scatterbrained and skittish of the whole crew. She hangs out with the new girls the best. She behaves well with the new ones, I think, because she herself is kind of ostracized from the original flock. So she gets along with the new ones who are all ostracized from the original flock because Mary keeps kicking their butt. So let's build now a flock containing Bertha, Marge, and Nancy. And let's talk about what we can have.
Is Mary the white one?
Mary's the one. She's the Delaware. I had to get it because she was Delaware. That's the breed. That's where I'm from. Turns out she's just like every other East Coaster I've ever met. Belligerent, loud, and aggressive. So, flock number 3. I've threatened to make soup out of her so many times. I'm out there cooking. Me and Max will catch trout sometimes and bring some home and eat them, and then some of them, for whatever reason, we have too much, or we have the bones left over, and I go outside and I kind of cook them up. I mean, like, we go out and cook up the remains for the girls, and as I'm on the fire cooking them for the chicken, she walks up and pecks me with the calf. So I kick her. Take her across the. She comes back and pecks me again. I'm like, I'm making you dinner. You stupid little leftover dinosaur. I'm making you dinner. And she keeps pecking me, and I swear to God, if she wasn't 3 years old and designed to be a layer, she'd already be soup. But it's okay. It's all right. 3 birds. Number of girls. How many can we have?
0, 1, 2, 3.
You're seeing a pattern there, yes? You're seeing a pattern 0, 1, 2, or 3. So every time we add a bird, we're adding a possibility. We could have that many chickens now, that many hens. Probability of that many birds. Okay. Who wants to take a stab at any of them?
Well, 0, would it be 0.1 times 0.1 times 0.1?
There's a nice pattern there, isn't there? The chance of them all being roosters is becoming exponentially smaller. This is going to be 0.1, if I may, cubed. Is that okay? Just to make the math easier, is that all right to do that? 0.001. Notice it's getting harder and harder to get all boys by a factor of 10 each time. And that should make sense, because every time you go back in and grab a bird, there's only a 1 in 10 shot you're going to get a boy, so it's 10 times less likely. Good. Which one's the next one that's easiest to do? You guys have already figured out the pattern. The ends are very easy to do. The chance of getting all 3 girls, would then there be 0.9 cubed as well? You notice it's also getting harder to get 3 girls. This is going to be 0.81 times 9. 0.729, I think I'm doing the math right. About 73%. Notice how it's getting harder and harder to get all 3 girls. It was 90, then, well, excuse me, it's getting harder and harder to get all girls. It went from a 90% chance to an 81% chance to a 72.9% chance. It's getting harder and harder to get all girls, right? That means it's getting easier and easier somewhere in the mix to get a boom. That was my point in the story. It's getting easier and easier somewhere to get a boy. Not necessarily all boys, but just somewhere in here. So Sarah, your point again. We now can figure out what these two have to add up to, don't we? This is 72.9%, that's 0.1%, that's 73% total. 27% of which has to exist in here. I just don't know how much is here and how much is here.
Well, I think I understand it. So
Yeah, you do.
If you were to get 1 bird, would you times 0.9 times 0.1, 0.1?
Okay, everybody follow that logic? Sarah just said to get 1 girl, I have to get 1 girl, which is 0.9, and then 2 boys, which would be 0.1 squared. Is that fair? Because you have to have 3 multipliers altogether. 1 for each bird. And each bird carries a weight. I think we looked at this in 105 at some point in 105, something similar to it anyway. So each of the girls carries either a 0.9, excuse me, each of the birds carries either a 0.9 or a 0.1 depending on its gender. So this would be 1 girl, 2 boys. This would be 2 girls, 1 boy. Yes? The problem with those numbers, I'm going to turn that screen off for just a second.
And then do you do it 3 times?
Now, the question is, actually with the screen on, thank you for asking that question. This isn't enough, correct? If you look at these numbers, this is 0.9, is 0.81 times, that's going to be 0.081, correct? I think if I did the math right, it should be 0.081. Check my math on that one.
I got 0.00.
Oh, no, that's down here. Sorry, that's down here, 0.081. This is 0.009.
Yes.
Thank you, Jen, and check my math. I think this is right now. Because this times this is 0.81, that moves it over 1. 0.081, just double check me. That doesn't sum up to the right number, right? That does not sum to 100%. It sums up short. So the question then becomes, Where did we mess up? Well, we only messed up a little bit. We have to adjust these probabilities because there's more than one way for them to happen. When I put 0.9 followed by 0.1 and 0.1, that means that Bertha's the girl and these two are the boys. Couldn't something else happen? Couldn't Marge be the girl and Bertha and Nancy be the boys? What else could happen? Well, careful. All girls is down here. No, you got, I love this. I love this, sister. I love this. So either, let's go through it together. Either Bertha's the girl and Marge is the boy and Nancy's the boy. Or Marge is the girl and Bertha's a boy and Nancy's a boy. Or Nancy's the girl and Bertha's the boy and Marge is the boy. Anything else? That's it, right? You've just assigned the sexes in all the ways you can, which means rather, now if it's okay with you guys, I don't want to write that out 3 times. Well, how about not cube it though, careful.
Multiply it by 3.
Right, times 3, which will be adding it together 3 times. If you cube it, it's actually going to get smaller. If we multiply it by 3, it's that plus itself again. Because if you wrote it out like we did over there, it would have to be, watch this, 0.9 times 0.1 times 0.1 plus 0.1 times 0.9 times 0.1 plus 0.1 times 0.1 times 0.9. I need a yawn now. That's ridiculous, right? It's going to get crazy to do that over and over again. Let's just multiply it by 3, right? Times 3, which should be, I think if I did the math right, let's just put it over here. 0.027. I think that's right.
Yeah.
That would be itself added 3 times. Same thing's going to happen down here, yes? There technically should be, you know what, let's make this a little bit easier. Let's just do this. I'll put the 3 out front here. 0.027. There we go. That's the adjustment. This thing, FYI, is called the binomial coefficient. Put that in the back of your mind right now. Don't memorize it. We'll come back to it on Thursday. Next question. Is everybody okay with that logic, that putting that 3 out front? That's the only way to arrange the sexes. Now you have to pretend, Zach, to go back to your awesome analogy, you have 3 dice now. You're past 2 dice, you now have 3 dice, and there's 3 ways you can tilt the dice around. Is that fair? Good. How about 2 girls and 1 boy? All right, I'll go for times 4. Show me what they are.
Girl, boy, boy, girl, girl, boy, boy, girl, girl, boy, boy, girl.
Boy, boy, girl we can't use. Because you have to have 2 girls. Okay, with Zach, oh, I love what you're doing, Zach. May I? When he's orange. Thank you. Zach is doing it a different way. He's actually listing B's and G's for arrangements. So 0 girls would be boy, boy, boy. 3 girls would be girl, girl, girl. 1 girl would be either girl, boy, 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 girl, boy, or boy, boy, girl. That's here, right? This one, this looks just like your guys' third project at 105. It comes back to haunt you again. 2 girls, 1 boy would be, you said it yourself, girl, girl, boy, girl, or boy, girl, girl. That's it. Your 4th one that you said is actually already accounted for up here. It's okay, brother. I love what you're doing. I love what you're doing. So what's the multiplier? It's still 3. Now, if you don't believe that, if you hate this boy, girl, girl, Morse code sounding thing we're doing, which I think is great, just put the sexes up there. Bertha's the boy. Marge and Nancy are the girls. Marge is the boy. Bertha and Nancy are the girls. Nancy's the boy. Marge and Bertha are the girls. That's it. You've assigned the boy. Whatever isn't a boy is a girl, according to the way we assign these sexes. Does that make sense? Is that fair? Let's make sure it works mathematically. It was 0.081, that should be 0.243, I think. Let's check that math to make sure that sums up. This plus this is 27%, which I think is what it had to be, right? Because this is 73%. There's your 100%. There's your 100%. Hot damn.
What are the numbers?
Oh, 0.001, 0.027, 0.243. I'm sorry, I'm going to mess up. There. So 0.001, 0.027, so 0.1%, 2.7%, 24.3%, 72.9%. This is when I start getting interested. Because it's 73% chance that you're going to get all girls. That's pretty high. 24.3 is a pretty high percentage. All of a sudden, there's a pretty good chance I've got at least a rooster in the box, huh? Right? If you look over there, the chance of getting a rooster is fairly small, fairly small, fairly small. All of a sudden, when you start buying more and more girls, you start getting more and more birds. You start getting a little more likely to actually have a boy mixed in there somewhere. That's what I was concerned about. I didn't want a rooster in the town of Bend. I didn't want one. Don?
What if you bought one rooster at 4 different stores?
One bird from 4 different stores. Great question. Don asked the question, what if I bought one bird from 4 different stores? I have never been told the percentage is anything other than 90%, which means I'm assuming that all the breeders are getting their birds from places that are doing 90% breeding, as far as 90% sexing. So it wouldn't matter if you bought 4 birds from 4 different stores, or 1 bird from 4 different stores, or 4 birds from 1 store. Numerically speaking, it's the same question. Your question is actually a great one. My grandfather asked me when I was like 10 years old. I play the same lottery number every single day, and I have for 30 years. Do you win? He's like, yeah, about once every 3 years. And I explained to him over the course, as I started understanding probability, I was like, you could play a different number every year and win once every 3 years too. He's like, that's BS. Felix, I love you. And the reason is simple. If it's a 3-digit lottery number, you have a 1 in 1,000 chance of winning. If you're guessing 10 numbers, 1 through 10, over 3 numbers, it's a 1 in 1,000 chance of getting all 3 numbers right. 1 in 1,000 played once a day means every 1,000 days on average you're going to win the lottery. That's every 3 years-ish. So if you just change the number every 3 years randomly, you're going to win every 3 years on average. And if you use the same number, that number will come up on randomly every 3 years. Same exact logic here. It's not going to change. It's not going to change when you put the same number every day or change the number every day. Same store or 4 different stores. It's still 90% chance for every single one of them. Is that fair, Don? It's a great question. It's a great question. What was it? We failed to do one thing. Let's wrap up. We'll build my flock on Thursday. I forgot to ask what was the average number of girls over here. We did the average number of girls per bird. It was 0.9. Stephen gave you that. What was the average number of girls if you have two birds in the flock? Can we do that? Yeah. The average number is 0 times 0.1, or 0.01, excuse me, plus 1 times 0.18 plus 2 times 0.81. Just a weighted average. That's all it is. 0 plus 0.18 plus 1.62, 1.8? 1.8 girls per 2 birds. Does anybody see a nice connection between that number and this number?
Double.
It's double. Because every time you add a bird to your flock, how much of a girl are you getting? 0.9. You're getting 0.9 girls for every bird you add to your flock. We now have comfortably, on average, more than one girl per flock of 2. What would the average be for 3 over here? Wouldn't it be 2.7? You can work it out mathematically if you want to. But what you're discovering is this is a very special kind of distribution. This is not rolling dice. I mean, it's kind of rolling dice. It is rolling dice in the fact that you're rolling a 10-sided die every time you stick your hand in the bin. And there's if you roll a 1, you get a rooster. And if you roll a 2 through 10, you're getting a hen. It's that kind of die roll. But when you analyze them all together like this, it's a different kind of distribution. We'll talk more about it on Thursday, which is about out of time. We're not going to have time to go. We'll add Mary, nasty Mary in the mix on Friday. And well, maybe they'll make 2 out of her by then. Who knows? We're still going to analyze her though. Okay, no? All right, more on this on Thursday. It's good stuff. This is a very important distribution.
Sean?
Yes?
Did you round to the 1 in 3 chance?
I did! You got it, don't you? Yep, he's got it. I did round because I couldn't do the math in my head very quickly. I changed